In this video, we're going to dive into addition and subtraction identities. Whether you're a beginner or looking to refine your skills, this tutorial has something for everyone. So without further ado, let's jump right in. So we have six addition and subtraction identities. We have sine A plus B equals sine A cosine B plus cosine A sine B. Then for sine A minus B, that becomes the difference is subtraction here. Then for cosine A plus B, cosine A cosine B minus sine A sine B, then cosine A minus B, that's cosine A cosine B plus sine A sine B. Then tangent A plus B is tangent A plus tangent B, then 1 minus tangent A tangent B. Then for tangent A minus B, that's tangent A minus tangent B divided by 1 plus tangent A tangent B. Okay, how are we going to use these identities? So let's start with the first example. So find the exact value. Find the exact value of the following. Okay, number one. Let's say we have sine 15 degrees. So how are we going to find the exact value of sine 15 degrees? The step here is to look for two angle measures that when you add or subtract, the result is 15, such that the two angle measures are special angles. And that would be 45 minus 30 or 60 minus 45, either of the two pairs. So sine 15 is the same as sine 45 degrees minus 30 degrees. Meaning to say, sine 15 is just equal to, we're going to use this identity, right? The second identity. So, sine 45 cosine 30 minus cosine 45 sine 30. So, the equivalent of sine 15 degrees is sine 45 times cosine 30 minus cosine 45 sine 30. Then we find sine 45, special angle, the value of that is square root of 2 over 2. Cosine 30 is just square root of 3 over 2. Then minus cosine 45 is also square root of 2 over 2. Then sine 30 is 1 half. Okay? If you do not remember how to find the value, that special angle, so you can use our calculator. So let's say, make sure that the mode of the calculator is in degree when the given angle is in degree, and radian kung radian. Let's say sine 45. So sine 45 is just equal to square root of 2 over 2. Then cosine 30 is just equal to square root of 3 over 2. Then cosine 45, that's square root of 2 over 2. Then sine 30 is just equal to 1 half. Okay? So then we simplify. Square root of 2 times square root of 3 is square root of 6. 2 times 2, 4. Square root of 2 times 1, that's square root of 2. Then 2 times 2, 4. Then, since we have a similar fraction, so we can combine. We have square root of 6 minus square root of 2 over 4. And this is our final answer. If we want to check, so we can use our calculator if we got the right answer. So sine 15 equals, square root of 6 minus square root of 2 over 4. Okay, next example. Let's say we have to find the exact value of cotangent 75. tangent 75 degrees. And we know by reciprocal identity that cotangent 75 is the same as 1 over tangent 75 degrees. So you can use the identity for tangent, then later on you get the reciprocal to find the value of the cotangent. So we're going to express tangent 75 degrees as a sum or difference. That would be tangent 45 degrees plus 30 degrees. This is the same as tangent 30 degrees plus tangent 45 degrees. So we're going to use the fifth identity, this identity. Okay? So that would become tangent 45 plus tangent 30 degrees divided by 1 minus tangent 45 degrees tangent 30 degrees equals, so tangent 45 is 1, so we check tangent 45, so that's equal to 1, so 1 plus, then tangent 30 is square root of 3 over 3 divided by 1 minus tangent 45 is 1, then tangent 30 is square root of 3 over 3. So simplify. So cos 1 times 3, that's 3, plus square root of 3 divided by 3. For the denominator, that's, since this is 1, we can just ignore this one. So 1 times 3 is also 3, minus square root of 3 over 3. So you can see we can cancel 3. Therefore, we have 3 plus square root of 3 divided by 3 minus square root of 3. So this is the value of tangent 75 degrees. Then we find the value of cotangent 75. So therefore, cotangent 75 degrees is just the reciprocal. We have 3 minus square root of 3 divided by 3 plus square root of 3. If we want to simplify this, so we can multiply 3 minus square root of 3 divided by 3 plus square root of 3. So you can multiply this by the conjugate of the denominator. That's 3 minus square root of 3 over 3 minus square root of 3, which is equal to 3 times 3, that's 9. Then twice, so 3 times negative square root of 3, that's negative 3 square root of 3 times 2, so negative 6 square root of 3. The negative square root of 3 times negative square root of 3, that's positive 3. Then for this one, 3 times 3, that's 9. Positive square root of 3 times negative square root of 3, that's minus 3. Simplify. So 9 plus 3 is 12, minus 6 is square root of 3. And that is 9 minus 3, that is 6. Divide both sides by, divide all the terms by 6. 12 divided by 6, that is 2. Then 60 by 6 cancel, so minus square root of. So the value is 2 minus square root of 3. This is the value of cotangent 75. So cotangent 75 degrees. Okay, we check. So we know that cotangent is the reciprocal, so we can use 1 divided by tangent 75. That's 2 minus square root of 3. So we are correct. Okay, how about for this next example? Let's say we have cosecant pi over 12. So cosecant pi over 12. First, we can convert pi over 12 to make the solution easier. So to convert pi over 12 to degree, since itong pi over 12 is radian, you can just multiply pi over 12 to 180 over pi. Okay? And that is equal to 15. So 15 degrees. So this is the same as cosecant 15 degrees. And we know that 15 degrees can be expressed as 45 minus 30 or 60 minus 45. For this time, let's use 60 degrees minus 45 degrees. Since cosecant is the reciprocal of sine, we can use 1 over sine, right? Or we solve first for the value of sine. That is sine 60 minus 45 degrees. Okay, we know that the formula for that sine is just sine 60 cosine 45 minus cosine 60 sine 45. So sine 60 is square root of 3 over 2. Cosine 45 is square root of 3 over 2. Cosine 60 is 1 half. Sine 45 is square root of 2 over 2. Okay, sorry for that the correction here. So this should be 2. Okay. Then simplify, square root of 3 times square root of 2, that's square root of 6. 2 times 2, 4. 1 times square root of 2, square root of 2. Then 2 times 2, 4. We have square root of 6 minus square root of 2 over 4. Okay, and then we get the reciprocal since we are talking of cosecant. So therefore, cosecant pi over 12 is the reciprocal, which is 4 over square root of 6 minus square root of 2. If you want to simplify, we can multiply by the conjugate. So 4 square root of 6 minus square root of 2. So you multiply by the conjugate, that's square root of 6 plus square root of 2. Square root of 6 plus square root of 2. So 4 times square root of 6 plus square root of 2 divided by square root of 6 times square root of 6, that is 6. Square root of negative square root of 2 times positive square root of 2, that's minus 2. So we have 4 square root of 6 plus square root of 2 divided by 6 minus 2 is 4. So this will be cancelled. So we have square root of 6 plus square root of 2. So this is the value of cosecant pi over 12. Okay, let's check if we get the same answer. So cosecant is just a sine reciprocal, but the given is radian. We change the shape mode, then for radian or region. So we find 1 over sine of angle pi divided by 12, which is square root of 6 plus square root of 2. So we arrive at the same answer.